Think of your Cambridge 0625 physics exam like a literal boss fight. Every single question is an attack pattern, and the examiner, well, they've laid out these traps specifically designed to drain your marks before you even realize you've made a mistake. And the ultimate fatal trap hiding right in plain sight? Unit consistency. You could memorize literally every energy transfer and power equation out there, but if you step into this trap, your flawless physics knowledge absolutely will not save your final grade. Okay, let's test your armor right now. Picture this. A student calculates speed using distance measured in meters and time measured in hours. So which answer format is actually correct for the final calculation? Is it A, meters per hour, B, kilometers per hour, or C, meters per second? Lock in your answer. This right here is exactly the kind of split-second decision that dictates whether you secure that top band or just bleed easy marks right out of the gate. Okay, let's dive into this. If you thought you could just slap m/h on the end of your number or somehow magically jump to km/h without changing the base distance, well, you've just triggered the fatal trap. Mixing meters and hours in a raw calculation leads to absolute disaster. The only acceptable derived unit here for standard physics equations is meters per second. This means before you even think about touching your calculator to divide distance by time, you absolutely have to convert those hours into seconds. Otherwise, you've created a fatal mismatch. To survive this, we need a quick win, and it starts right here with this basic SI unit table. Using consistent units is basically what allows us to compare the sizes of variables and actually trust our math. For length, your base is the meter. For mass, the kilogram. For time, it's the second. Now, the examiner's absolute favorite trick is feeding you data in that common traps column on the right. They'll give you distance in millimeters, mass in grams, or time in hours. And if you plug those trap units into your standard equations, your final answer is going to be completely wrong, even if your math itself is totally flawless. Now, watch how this builds into higher-level concepts like energy, work, and power. These are your derived SI units. The Newton, the joule, the watt. These aren't standalone things. They are built entirely on those basic SI units we just looked at. A joule of energy is literally defined using kilograms, meters, and seconds. So here's the crucial takeaway. If you calculate kinetic energy but accidentally use grams instead of kilograms for mass, your derived unit just collapses. You aren't calculating joules anymore, you're calculating a totally meaningless number. Just one wrong base unit completely infects the entire equation. Now, in just a second, I'm going to show you the exact examiner clue that changes how you approach these calculations completely. It's a clue that is always hiding in plain sight on the exam paper. But before I reveal that secret, you really need to understand the structural framework that makes this clue so glaringly obvious once you know what to look for. To secure those top band marks in Cambridge 0625, you need to attack every calculation and explanation using this four-step framework. First up, identify the underlying concept, say kinetic energy. Second, extract the evidence or data from the question, and listen, this is where you ruthlessly check your units. Third, apply your scientific reasoning by grabbing the correct equation. And finally, output your answer using precise examiner wording and the correct derived unit. If you skip step 2, if you don't verify those data units, steps 3 and 4 are 100% guaranteed to fail. Section 1. Escalating the stakes. Area and volume unit conversions. And this brilliantly illustrates the exact trap I'm talking about. So, you've mastered the basic base unit conversions, right? Well, the examiner knows that. To really test you in pressure or thermal physics questions, they bring in area and volume. Notice the shape here. We have a length of 20 centimeters, but a width of 10 millimeters. The fatal mistake is immediately multiplying 20 by 10 to get an area of 200. But 200 what? The units don't match. Before you do any multiplication, you must force consistency. You have to convert that 10 millimeter width into 1 centimeter. Now you multiply 20 centimeters by 1 centimeter to get a perfectly consistent area of 20 square centimeters. Always, always match the units before you apply the formula. But here is the ultimate boss attack in this explainer, converting squared and cubed units back to standard SI base units. Let's say you successfully found the area in square centimeters, but the formula for pressure requires standard square meters. You might naturally think, oh, there's 100 centimeters in a meter, so I'll just divide by 100. Wrong. Because it's an area, it's 100 centimeters times 100 centimeters. You literally have to divide by 10,000. And for volume, going from cubic centimeters to cubic meters, you divide by 1 million. This single table right here is where grade boundaries are won and lost. I want you to act as the examiner for a second. Take a look at this student's flawed answer. They calculated an area of 5,000 square centimeters, and they need to convert it to square meters to finish off their physics equation. So they divided 5,000 by 100 and got 50 square meters. Spot the fatal error. Take a quick second. Why is this student about to lose all their remaining method marks? Now, what's truly alarming here is the sheer scale of the error. On the left, the flawed answer divided by 100, resulting in 50 square meters. But look over at the right, the top band answer. By correctly dividing by 10,000, because it is a squared unit conversion, the actual area is 0.5 square meters. The flawed answer is exactly 100 times too large. Think about that. If you plug 50 square meters into a pressure calculation instead of 0.5, your final answer is entirely ruined, all because of one misunderstood conversion factor.
Let's forge your armor before we wrap up this explainer. This is your ultimate unit consistency checklist. 1. Always identify and convert to base SI units, meters, kilograms, seconds, before running any calculations. 2. Remember that derived units like joules and watts demand base units to actually function. 3. If you're calculating area or volume, force your length units to match before you ever multiply. And 4, when converting squared or cubed units, apply those massive conversion factors, 10,000 for area and 1 million for volume.
You've successfully survived the unit consistency trap. Take a breath. But the exam boss fight isn't over. While your numbers might be perfect now, what happens when you misinterpret what the examiner is actually asking you to do? The command word trap is up next. And if you can't tell the difference between describe, explain, and evaluate, even perfect math won't save you. You're still completely vulnerable. Proceed immediately to our last 7 days revision map to master the command words and complete your armor. Subscribe to our YouTube channel AC Exams at acexams_IGCS to excel in your Cambridge examinations. See you in the next phase of the fight.